Hello everyone. In this presentation, we will be looking at the analytical framework our team developed to analyze the different threats and security vulnerabilities to hardware security. To begin, the world of cybersecurity is a complicated mess of information. With more than 2,200 cyber attacks per day, it is no wonder why cybersecurity has become an organizational nightmare. While researching into hardware-based security solutions, we realized just how broad and scattered the topics of cybersecurity really are. At one moment, we are concerned with the technical post-fabrication attacks such as rowhammer or differential power analysis, and the next we're considering a supply chain attack such as hardware Trojan insertion. These attacks are in no way linked to each other and are very hard to visualize in the grand scheme of analyzing a product's security. So a big problem arose. We needed a process to systematically analyze the cybersecurity of a product while simultaneously organizing the possible attacks that need to be considered. In other words, we really just needed a place to start and list information down. And over this time, we put together a very simple yet effective analytical framework to visualize and standardize cybersecurity attacks. On this slide, you can see the organization table, which is the visualization of cybersecurity in our analytical framework. It's important to note that we are classifying all types of cybersecurity attacks into three classifications. The first one being subversion, which is altering the functionality of an IC to an adversary's advantage, so any type of alteration of the chip. Some examples are backdoors, logical hardware trojans, or material modification. The second classification is appropriation, which is obtaining data from the IC. Again, this can come in many forms, such as side channel attacks and various physical attacks, but the main objective is to obtain data from the IC. And finally, we have sabotage, which is intentional selective destruction of equipment. Sabotage can come in many forms. It can also be done by subversion or altering the IC. And some examples are DDoS attacks and ransomware. But the important thing is to note is that this gives us a place to start by classifying the cybersecurity attacks into the three categories. Now let's take a look at a quick example. Say you're in the process of developing or analyzing for purchase an FPGA-based radar data security unit. What we have done to analyze different products is first break down the process into distinct implementation steps. So for an FPGA device, the steps that we consider are system specifications and requirements. That leads to design constraints, which leads to designing the HDL. That leads to the FPGA board selection. That leads to generating the bit stream. And finally, we have the deployment and usage in the field. So now we have 6 distinct steps of the entire creation from start to finish of an FPGA. These steps are then listed on the data visualization table in the gray subcategories, and they go in the sequential order of how they happen in the development phase. So our first step here, we'll put a 1 here, and then we will put the name of the first step, which is system specifications and requirements. We will now fill out the rest of this table. Now that we have all the steps laid out, the next thing to do is identify the attack surfaces for each step. An attack surface is a collection of points an attacker can use to perform an attack. One such example is the supply chain as a whole. Another example is one component of the supply chain, such as a components manufacturer. These attack surfaces can be custom, and there can be more than one attack surface, and most of the time there will be more than one attack surface for each one of these steps. For our FPGA example, we're going to take a look at step number 3, and we're going to identify the attack surface of the HDL code designer. Now let's start considering some attacks the code designer can perform. Under the classification of subversion, meaning altering the functionality of a chip, a HDL code designer can intentionally insert a hardware Trojan. Another example is using untrusted third-party IP libraries and design tools. An example of appropriation is the piracy of the HDL code or supporting files. Another example is reverse engineering. Finally, an example of sabotage is adding or removing components to destroy the functionality of the IC, or adding a block bypass, for example, bypassing the cryptography block in the circuit. Now let's take a look at a few more examples. On step number 6, we can identify the attack surface of the IC being in use or fielded in deployment. Some examples of subversion are signal, clock, and power glitch. Another example is rowhammer attacks. An example for appropriation is power consumption analysis. Finally, for sabotage, we can do something like RF blocking and jamming. Hopefully, our analytical framework we developed while researching hardware-based security will bring some visualization and organization to the world of cybersecurity, and if nothing else, will provide a good starting point to start visualizing and categorizing the different threats and how to tie all them together while performing a security analysis. Finally, a full example will be documented on the final report delivered at the end of our project.